My inverter get burned not cause of the overload, not cause of the temperature, not cause of the short circuit. It get burned by ants. It's not important if you have a short circuit overload. Your inverter can be burned by this ants also, lizard also. It can destroy. The insects are really very big problem if you are in messy environment. When I opened this inverter, the ants was everywhere in the MOSFET's legs and the IGBT sides. So I hear one spark, but visually I not see any kind of spark or burn any side. It's clean, clear. I never see any kind of spark. Here you can see this is our DC voltage and this is our output voltage. The output voltage is 149. Here must be 230 to 20 volt. But here I cannot see the alarm light is on this inverter. You can see the fault light is not on due to its protection level. But sometime is happening, like this time my input wire is not getting hot and the fuses is never blow. Nothing is going wrong, but we have not good output. So the problem will be somewhere here. So this kind of fault, this kind of tracing you cannot do without oscilloscope. You must need one oscilloscope. Okay, the first we will check the gate signal on oscilloscope and see how's the signals. Okay, let me connect the scope to the MOSFET gate very carefully. Okay, here is connected. The signal is clear. You can see we have 32 kilohertz frequency and square wave. That is first MOSFET. Let's check all. Now connected to the second MOSFET gate and signal is clear, frequency is correct. Third MOSFET, signal is correct, frequency is correct. Fourth MOSFET, and here is. Now you can see the gate signal is totally abnormal. Okay, but the frequency you can see 33 kilohertz and the voltage very fluctuating on the gate signal. That is mean this MOSFET have short or leakage. Number 11 clear, number 12 and clear. So all MOSFET have a signal except this number 4. Okay, very carefully connected to the gate signal. You can see the signal behavior. Okay, very abnormal. Okay, let me remove this MOSFET and then we see the signal response on this gate, cause this is we called the pull transistors. Okay, so if you want to confirm the pull transistor also, you have to check the signal here. If here in this MOSFET number 4, okay, that is MOSFET number 4, if in this gate after removing the MOSFET, this one, the signal if still same like that, it means the problem of that pole is here of this number 4. 1 2 3 4, number 4 pole is here. Okay, that means the problem on that side, on that transistor, the pole transistor. Let's remove this one first. Now the probe are connected on number 4 and here is, we can see we have a 32 kilohertz and clean square wave signal. So it means this bunny have a problem. Let's check this one also. Let's discharge this MOSFET first. And Now we check the this one is from drain to source is short, but from gate to drain is okay, gate to source is okay, but this one is short. Okay, that was the problem. Now we see the input is 20 volt, the output is still 150-60 volt. In that condition, when your DC side MOSFET okay, IGBT is okay, so the problem is there. Did you see this optocoupler? There. Because that is the feedback, here is the voltage feedback and current feedback. So the problem is now in the feedback. This is the output capacitor of the DC stage, 450 volt DC, 390 UF. Here must be voltage is 320 or 380 volt DC must be here. So let me check the voltage here, how much is we have a output here. Now the probe is connected, and here we have our DC voltage. That is a 210 volt DC, which is 50% of the RMS value. It must be 320 or 380 volt here. Okay, but we have a very less voltage on caps. It's mean we have a problem in the feedback. Okay, it is still 150-60 volt. In that condition, when your DC side MOSFET okay, IGBT is okay, so the problem is there. Did you see this optocoupler? There. Because that is the feedback, here is the voltage feedback and current feedback. So the problem is now in the feedback circuit. You must care about your installation. Always keep eyes on the insects, or if they have a laser, ants, you do cleaning, use some spray. This inverter I'm not going to repair it because I have to claim the warranty, and just that's it. And the fault sometime on the MOSFETs that without oscilloscope you cannot diagnose it. So it's very important tool. Okay. This is 2000 watt pure sine wave inverter, which is very professionally built. This is the DC side MOSFETs. Here we have IRF 1407. This is 130 amp rated MOSFET, 74 volt, best for 24 volt application. And here is the IGBTs, 60 amp rating. Very perfect and clean design. Output inductor and capacitor. Here is the output stage. Inductor is a quite big, you can see, and here's the capacitor. This is the fuses for each transformer input. The positive input, the ground is a common, negative. Here is this one is the PWM module. Here is the protection circuit, and here is the pure sine wave module, regulator. That is our capacitor. After this output of transformer, the rectification, the voltage is here stored on 450 volt 390 UF capacitors in parallel. You must care about your installation. Always keep eyes on the insects, or if they have a laser, ants, you do cleaning, use some spray. This inverter I'm not going to repair it because I have to claim the warranty, and just that's it. And the fault sometime on the MOSFETs that without oscilloscope you cannot diagnose it. So it's very important tool. Okay.